Let me just say thank you very much again for the invitation, Victor, and putting together a really nice program these last 2 days. And of course, it's it's a shame that we can't be in Oxford, but it's still a lot of fun to participate. So the paper that I want to present today is, so the paper is called US Monetary Policy at the Height of Financial Crisis, a Constrained Optimal Policy Projections Perspective. And this is work which is in progress. There's kind of a sequence of papers that I've been working on with colleagues at the ECB, with Falk, Roberto, and Anuka. And what I wanted to do today, rather than kind of present the paper in its kind of current form, I wanted to focus on some aspects of the paper which were more kind of relevant for thinking about forward guidance and how we think about forward guidance in DSG models. And so, a large part of the paper is kind of focused on QE, and so I'm gonna skip over that. So as I said, so the currently actually available version of the paper has a different title. It's actually called A Toolkit for Computing Constrained Optimal Policy Projections. The new version of the paper is more focused on a policy application of studying the optimal mix of interest rate policy and QE. But today, as I said, what I want to try and do and convince you of is that this way of solving optimal policy problems, what's called an optimal policy projections approach, right, is also interesting in the sense that it sheds new kind of light on the nature of the trade-offs that face central banks, and especially the nature of forward guidance within new Keynesian models. So this is, in some sense, an experimental presentation to try and convince you that there's some kind of pedagogical value in this approach. And then I'm kind of very interested to see if you kind of buy this story, you think there is some pedagogical value or not. Yeah, so really interested in kind of your feedback for sure. So let me kind of jump straight in and kind of give you the basic idea. I'm not going to go into all the technicalities, but the basic idea of the optimal projections approach, right, is that the typical way that we would solve optimal policy problems is we start off with an objective function. Here it's linear quadratic, and we're going to the policymaker is going to choose the control variables subject to the private sector equilibrium conditions which act as constraints. So the idea here of optimal policy projections is that instead what we're going to do is we're going to make the choice variable of the policymaker a sequence of policy shocks. So that's a kind of unanticipated contemporaneous shock and new shocks or anticipated policy shocks. And we're going to use that vector of policy controls to construct an optimal policy path or an optimal policy projection. And so the constraints on the policymaker are going to be the impulse response functions that come out of those policy shocks. So the idea is, one, that this is under certain conditions is going to generate exactly the same equilibrium outcome as kind of your standard way of solving optimal policy. So in that sense, the results that I'm going to show you aren't anything new. And in fact, what I'm going to focus attention on for the majority of today's talk is essentially replicating some examples from the Jordi Gali New Keynesian textbook. And but then try and convince you that this alternative way of constructing the optimal policy path allows you to kind of disaggregate that path in some sense and learn something new.
Oliver,
all right.
May I ask a question?
Yes, of course, yes.
So here, the typical way in which you approach these problems is to find out what is the optimal relationship in the endogenous variable that the bank should do. What is the relationship between output and inflation that minimizes those welfare losses? What you are saying is that I'm not going to do it in terms of observables, in terms of output and inflations. I'm going to do it in terms of shocks. Is it what you are doing, that now you will do this minimization and you will find the optimal relationship between shocks that deliver the minimization of that objective function? But then if you do so, are you making yourself a favor that instead of looking at the observable, you work with the unobservable? So right now, I don't see the advantage. I'm sure there is one, but if you could briefly touch on those, if my interpretation is correct and that is the way in which you will progress, that would be helpful.
Yeah. So as in this toolkit that we developed, which is kind of actively used within the ECB now for the policy process, right, has kind of computationally a lot of advantages, right? That's not what I want to get into today. So we can have a discussion offline about why you would want to set up construct optimal policy solutions in this way, right? And why at a central bank this is kind of a useful thing to do. So I know yesterday there was a lot of people in the workshop who are at the Federal Reserve. They would be kind of familiar with this optimal projections approach. The Bank of England use it as well within there. So one, we build on this approach in several ways. Again, this is not what I'm going to highlight today, but the paper highlights this. So of course, have a look at the paper. I'm going to try and convince you that there is kind of an additional benefit, which is that it provides some additional intuition. Now, whether it does or not is that's kind of my test today. So I'm going to present it, and then you can tell me at the end. First of all, you can tell me. We all know the textbook example. We all understand how it works. You're trying to teach your granny how to suck eggs here. And we learn nothing new, right? That's if you tell me that, that's fine.
But what I hope that you can tell me now, is it my understanding correct that you will look in the relationship across the shocks instead of the observables, and you will tell us then stories why that is advantageous compared to? Is it the gist of this paper?
Yes, in part. Well, it's not the gist of the paper. It's the gist of the presentation. Yes.
Yeah.
Right. So
okay.
Exactly. In that sense, you're absolutely right. That's what I'm going to do, or try and convince you of. So as I said, just in terms of notation, right? We, the things that the policymaker is controlling is this vector of policy shocks, VT, that are, essentially, go out to infinity. We're going to take a finite approximation of those. So we're going to have a vector out to some large number. And these impulse response functions are going to come from the same model, but in generating these impulse response functions, we have to introduce a policy rule. One thing that's really important is that this policy rule is arbitrary in the sense that the policy rule itself doesn't affect the optimal policy outcome, right? But it's important in the construction of the policy outcome. So in that sense, this policy rule is going to be ad hoc. But so, one way you want to think about this approach, right, is that if you have all the impulse response functions to policy shocks from time zero out into the future, right, this contains all the information that you need to know about the model, right? Once you have this information, you can throw away the actual equilibrium conditions of the model. Right, so one, this is all we need. Another way to think about that is that, well, suppose I didn't have a structural model. Suppose I estimated these impulse response functions from some kind of time series model, local projections, a VAR, right? You could take exactly the same approach, right? Given an objective function and given that the policymaker knows the response of the economy to its policy shocks, we can construct optimal policy projections in the same way.
Sorry, Oliver, can I ask a quick question?
Of course,
I was wondering, here you are assuming policy functions as a statistical object, right? It doesn't mean that it is identified and that, it rejects the Lucas critic, right? It's just a statistical object, these policy functions.
So to the extent that in this presentation, I'm going to be working with a structural model. So these are going to come from a structural model. They're identified. The optimal policy outcome isn't going to be subject to the Lucas critique. Now, the question is, so I made this kind of analogy, right, which is said, well, if all I need is impulse response functions, maybe I can get these impulse response functions from somewhere else, right? I can take them from a var. Now, the obvious, and maybe this is the point you're making, the obvious problem that you have is that if you try and extract new shocks, anticipated shocks from a var, you're not going to be able to extract policy shocks at every horizon, right? Because, there's some collinearity between these, right? So you're going to at most be able to, estimate a couple, right? And then, so the only way in order to replicate what, the optimal policy path would be using, what I would call standard methods, right? One needs the complete, the complete set of impulse response functions. So with only kind of a limited information approach, like a var or a local projection, you wouldn't be able to recover, what you would think of as, the structural optimal policy path. So, again, I think that answers your question, but it's not really kind of the center point of what I want to present today.
Oliver.
So, yeah.
Another question. So here, when you do this exercise, basically what you work is with the state space of the model. No, you already impose the stability conditions. You rule out sunspots. Is it how it works? That in the previous stage, whereas in the normal way, you use the first order conditions, and so those they are still open to an all sorts of dynamics, that the state space that you use, you impose that those dynamics are not playing any role. Is it also what you do, or no?
Yeah, and this is an important point, and one that we haven't thought hard enough about. So I told you in the previous slide, in order to construct these impulse response in order to get these impulse response functions, you need to assume an ad hoc policy rule, right? Mm-hmm. Now, it doesn't matter what policy rule I put in there. The only requirement on it is that, the model then, still, the Blanchard-Kahn conditions hold, that you have stationarity.
Well, yes, exactly.
So what we haven't thought hard about is, well, what happens if you, specify, what kind of, implicit assumptions or restrictions does that actually place on the model, right? So it's a good point that it's something that we should think harder about. But so at the moment,
I don't think it's an issue, but I think you could leverage on it, that you can make that clear, and because it's interesting. Even if you do it under those conditions, it's interesting to see what happens, and then maybe next. So I'm not making a critique. I'm just saying that a clarification for me is enough now, but it's important.
Yeah. Good. No, thank you. That's a good point. Victor, I was going to say, already, lots of discussion on slide 2, which from my perspective is totally fine. So you just tell me, when I've got to finish, and then I cut short. I have no need to get to the end of my presentation. So please I'm happy with the discussion, and I'm happy to cut my presentation short whenever you tell me. So
sure, absolutely. I mean, if you aim for 12:30, I mean, maybe a bit earlier if questions remain, but we can always stay, as I say, during the break. The call is open. We can continue discussing if we need to.
Perfect.
But to let everybody stick to schedule, if you can be done at 12:30 tops, that would be great.
Exactly. Good. Sounds good. So here's the way to think about it. First of all, I can start off with some baseline path for the economy, right? So think about this as being, there's a shock and there's a non-optimized policy rule in place, right? And this is going to give you a path through the economy, right? From this as a starting point, the policymaker, you can ask the question, well, the policymaker wants to, construct optimal policy here. Given this path, what deviations does it want to make from this non-optimized policy rule in order to minimize its objective? Given that we're in a linear quadratic world, right? I can essentially take this baseline and linearly add on these impulse response functions. And so baseline plus impulse response functions gives me an alternative path for the economy. And given that, then all I'm going to do is I'm going to, select this vector of policy shocks so as to minimize my objective function. So as I said, this is kind of, so far I've given you kind of an introduction, hopefully not too technical way of thinking about what optimal policy projections are. Here I'm going to start to deviate from the paper, which is to say, well, how does this approach offer new insights into specifically forward guidance, because that's what we're about today, and policy trade-offs. So what I want to be able to do, which is difficult in solving for optimal policy in the kind of standard way, is that we can kind of deconstruct the optimal policy projection in several different ways. So one, which I kind of like a lot, is we can arbitrarily shorten this horizon H. So the number of policy shocks that are available to the policymaker. And as we increase H, we can kind of see how, we converge to the optimal policy path. And, under the belief that, we have a fairly good understanding of, when we look at an impulse response function of, what the kind of economic intuition underlying it is, then we have a better understanding, a better chance of understanding the optimal policy path that results. And then there are three other things which I want to touch on. One is that, when solving optimal policy, using this approach, is very easy to kind of span the two extremes of discretion and commitment with what we call limited time commitment, where the policymaker can commit for D periods and then re-optimize and commit for another D periods. So again, by being able to span this distance between discretion and commitment, I think we can get new insights. I'll try and touch on that a little bit. Third is that, again, because this way of thinking about the model and thinking about optimal policy as being, in terms of policy shocks, right? What we can do is we can play around with the way we kind of mitigate the forward guidance puzzle, how we dampen the effect of these anticipated policy shocks, and again, kind of extract from this how important forward guidance is. And so I think one thing that, I try and highlight here is that, a lot of people kind of think about, forward guidance only kind of comes with the zero lower bound, right? Where, the power of forward guidance and the forward guidance puzzle is embedded within the New Keynesian model, irrespective of the zero lower bound. And so this is something I kind of want to, show you or convince you of today. The fourth thing you can do here, which is very simple, is that you can very easily add kind of an arbitrary set of constraints on policy. And by adding these constraints, it allows you in some way to kind of, get a better sense of what the shape of the objective function looks like. So let me try and do those things. So what am I going to do? I'm going to start off with my, three equation New Keynesian model. I'm going to go to Ghali's textbook. I'm going to take out, the classic examples that that he uses. We have in the paper, in the appendix, we have a whole bunch of them. Here, I'm just going to focus on two. And then I'm going to try and, study the difference between a Taylor rule outcome and optimal policy. And so, the two scenarios I'm going to want to look at is one, the divine coincidence, and two, there should be an and in there. Sorry, there's a typo. So one, the divine coincidence, and two, a ZLB scenario. And then if I have time, I will show you one thing on kind of the trade-off between forward guidance and QE. So I'll try and squeeze that in if I can. So hopefully this picture should be, very familiar to, anybody who, has recently finished their PhD or who teaches a first year PhD class. This is kind of chapter 5 of the Ghali textbook, right? So we have a natural rate shock. We have a simple Taylor rule, and the outcome is this black line, right? Where the policymaker wants to ease the policy rate, but the policymaker doesn't, under the simple non-optimized Taylor rule, doesn't close both gaps. So inflation is still below target, the output gap is widened, right? Now, what's the result under optimal policy? In this scenario, optimal commitment and optimal discretion deliver the same thing. And we get the divine coincidence, which is that the policymaker can, perfectly close both gaps. The part that I think is, in some sense a puzzle, and you can tell me, it's not a puzzle, but, when I, talk to PhD students, try and, teach this part of the textbook, often, people find this kind of puzzling. So what's puzzling here is that obviously under optimal policy, the policymakers managed to close both gaps, but the policymaker hasn't had to ease the policy rate as much as under the baseline, right? So your intuition might be, well, the policymaker wants to close both gaps. Inflation was below target, the output gap was wide. The policymaker needs to be more aggressive in using this policy instrument. And so you'd expect the blue line, the policy rate, to be lower, but it's not, right? So, and I'm sure you can give me a perfectly good explanation about expectations and credibility, and that really we shouldn't care about the nominal rate and we should care about the real rate, and the real rate is clearly lower, and so policy is easier. But in some sense, these arguments or these explanations are kind of a little bit hidden to the student. You've kind of got to believe this story about expectations to to buy what you see here, right? Another way to think about it is, especially if you go and if you work in a central bank and you take a picture like this to a policymaker, right, and you go, you can tell the public that actually you're not going to ease policy as much, but inflation and output are going to be higher. They would say this is crazy, and this is crazy New Keynesian economics, which maybe is true, but at least let me kind of show you a new way of deconstructing this very simple picture that we're all very familiar with. The second one I want to look at, so I'll come back to that. The second one I want to look at is a zero lower bound scenario, which you can see here, and kind of decompose a little bit, especially looking at the blue line, which is the story about lower for longer, right? So the mantra that we all teach or get told is at the zero lower bound, optimal policy wants to hold interest rates lower for longer. Wants to create an overshooting of inflation expectations, which is going to lower real rates. So I want to kind of decompose that a little bit. I'm going to skip over literature, but there's a huge literature in this area. There's actually a lot of work on optimal policy projections, and also a very close related idea in the heterogeneous agent model called sequence space methods, which again kind of exploit this idea that a model is just a set of impulse response functions. But I don't want to get into that.
So, sorry, Oliver. So maybe I missed this before, but what you're talking about reminds me of this idea of modest policy interventions by Lieper and Jha, right? So they defined it until what point the intervention and the change in the policy is modest enough so that the impulse responses are still correct, and at what point it's amount to a change in the policy rule and the impulse responses changes. So this seems to me like a crucial assumption here, right? That all the policy interventions that you are considering are modest policy interventions in their sense, right? And they show a way how to test this statistically. Does that ring? Yeah.
Yeah. No. It's you make a good point. Again, it's an area where I think we need to do more work to kind of think about that, because when you compare the baseline, if the way you want to think about this is that the black line is the baseline forecast that a central bank is going to produce, right, and then you want to compare what they could do if they were really optimizing, right, then it's not necessarily a small policy intervention, right? And so the kind of the Lieper critique could be an issue. One thing, as I said, one thing we can do is we can add very easily, in a technical sense, a lot of different constraints that we want to add to the problem. Because, actually this way of solving the model is very efficient. And so one example that I'm going to show you is something that kind of gets close to this, which says, I want to optimize, but don't want to deviate too far from my baseline, right? And so what does that look like? So I'm going to show you one picture in that regard. But yeah, we don't in a formal way, constrain, how large these deviations can be. So in some respects, they could be large, and you would maybe be concerned about that. Okay, so as I said, back to the divine coincidence. So the black line is the baseline path which I showed you before. Natural rate shock, inflation widens, the output gap widens, and the optimal policy path is one in which both gaps are completely closed. But remember, the policy rate doesn't fall as far. But I don't plot that here. So here's a way of thinking about this, which is to decompose the problem into these individual shocks, right? So what we do is we start off with the dark blue line and we say, well, what would an optimal policymaker do if they were minimizing their objective function, but all they had access to was a single unanticipated policy shock, right? So they had essentially one instrument. What you can see is that they would ease monetary conditions aggressively, right? So you can see the dark blue line, they will cut interest rates very far. We're ignoring the ZLB at this point, right? And what they want to do is, you know, an optimal policymaker doesn't want both variables that enter in their objective function to both be, you know, below target, right? So the optimal thing is always to have, you know, one above and one below, which is what you see here. So the output gap is above target and inflation is below. Okay, and I think that is a pretty uncontroversial, easy to explain picture, right? So then we take it one step further and we say, okay, assume this policymaker again wants to behave in an optimal way, but it only has access to two policy shocks, an unanticipated one today, and it can make a promise about how it's going to act tomorrow, right? So this is H equals 2. What you can see the policymaker wants to do, because of the power of forward guidance here, right? It wants to do the easing of policy in period 2, right? So this is the light blue line. You can see policy is eased in period 2, but easing policy in period 2 because of expectations brings aggregate demand forward today. And so in fact, then, you know, the policymaker today actually wants to tighten policy a little bit. Okay, so it wants to offset some of that effect of you know, this kind of dynamic aggregate demand channel. So what you can see is that the policymaker wants to promise to loosen tomorrow, and today it's going to tighten a little bit. All right, again, you know, to my mind, this is you know, an uncontroversial way of thinking about it. Then, as you kind of,
but Oliver,
yes,
but as you, so basically, if you give many degrees of freedom, the policymaker will keep inflation and output gap at target until it can, until it has enough shock, and then you end up that all the reaction is where the policymaker will need to behave according more to the model without having these favorable shocks, and you have this huge swing in the end. So that would be, in a way, it's saying. So I don't know how to frame this in terms of expectations. So if the agents know it, that inflation and output gap will be on target for all these many periods, but then they know that there will be a huge blow. How should I think of it in terms of expectation, and what is the value of it? Like, if you tell me if you can do the shocks that you like, then you keep everything on target. I don't see any trade-off. I don't see anything.
So one, you know, if you look at these paths, right, it's not like for these first two periods, the policymaker is able to close gaps, right?
No,
so you see the light blue line here.
Yeah.
It's able to do better than the baseline, right? But what you will see, right? So then if we, you know, we can add these one at a time, right? Here, I've only shown you the next one, and H equals 8, but hopefully you can see the pattern. What does the policymaker do? It wants to, you know, the last instrument that it has, right? That's the point that it wants to ease policy, because through the forward guidance puzzle, right, or through the power of forward guidance in these new Keynesian models, right? This is where you want to promise to ease policy. And then in the entire, you know, period before that, you essentially then are going to tighten policy a little bit to manage the aggregate demand effect, right? And so what you can see is that this shock is getting smaller, and you can't really see it, but this green, you know, easing shock is getting smaller, right, relative to the blue ones, right? And this green path here, right, is now starting to kind of look like what I showed you here, right? It's starting to approach this line, right? So this is the way to think about it, or this is a new way to think about this picture that, as you know, as I said, we've all kind of seen 1,000 times, right? Is one way to think about this is that this is moving from the black line to the blue line, right? Is the same as a policymaker who is going to infinitely far in the future promise to ease policy by a marginal amount, right? And in the period between that is actually going to tighten policy to ensure that both output gaps are closed, right? So that's what you would continue to see if I was to plot this as h equals 16 or h equals 32, right? What you would see is that this path is going to converge to the full optimal policy path, and there's going to be this small shock that the policymaker is going to exploit far in the future, right? So that's what, you know, all I'm doing is, you know, then you can think about, you know, whether you like the three equation New Keynesian model and whether it, you know, bears any resemblance to the real world, right? All I really want to convince you of here is, when we think about the divine coincidence, a new way of thinking about how it is that the policymaker is able to close both gaps, right, is through this mechanism. Make one promise very far out in the future that is small, but exploits the power of forward guidance. And in the intervening period, it's actually going to tighten policy, right? That's what you see from this picture. That's you know, that's as modest, that's kind of my modest pedagogical insight. And then you can tell me if you like it or not.
But then you need to believe that forward guidance is such that you can really close these gaps. Because what you're saying, obviously, if you get the gap closed, then you deliver mechanically the optimal rule. That's what the policy optimal rates is based on, right? So
of course, right? So here I'm taking our off-the-shelf textbook three equation model, right? And then you can say, well, I don't like the three equation model. Fine. But, you know, when you know, kind of, you know, in some sense, the divine coincidence and the three equation New Keynesian model is at the heart of, you know, almost everything we do as monetary economists, right? So at least, you know, all I want to do is you know, at least in today's presentation is offer you a new way of thinking about that result.
But then how would so everything hinges on output and inflation remaining at zero for a sufficiently long period that gives this leverage to the central bank. How in your framework, what sort of shocks do you need to be there? What sort of policy do you need to be there? So you are saying
so this shock. So that's something I could plot, and I haven't, right? But this is, you've got these H periods, right? So this is your, you know, control vector for the policymaker. The last one is going to ease policy, right? The policy shock is going to be an easing shock, and every shock prior to that is going to be a modest tightening shock, right? That's what this looks like, right? And then as you extend this H out, this last shock is going to be an easing shock, but each time is going to be slightly smaller because the power of forward guidance means that it only needs to be, you know, and in the limit is going to be, you know, infinitely small, right? That's what it's going to look like. So now, and then you can see how the path through inflation, the output gap, is slowly converging to zero, right? You can see how they're, you know, we're kind of pushing down the path towards zero, right? This is what you can see in this green one, right? For the first 6 periods, basically close to zero, right? And as you increase H, this is how the policymaker is able to extend itself out. And these deviations, you know, are going to get smaller and smaller.
Oliver, I guess what Francesco is going at, and I think you explained it well, but it would be nice if you had a figure of the actual shocks. So kind of the inverse of the policy rate. So the policy rate relative to a baseline, just to see the difference.
You're absolutely right. Yes, I think that is something I should.
Another point that I want to make quickly, but you don't have to answer because I don't want to eat you in your presentation. Is this also, are you accounting that? Is it that do the agents know it ex ante? Is it in their expectations that they know that there's going to be a tough time and then an ease? Because that is important. And if rational expectation holds, I would have had another intuition but you can think about it. Maybe it's a short presentation, so
So the answer is yes. The private sector has got, you know, full rational expectations, right? In a second, I'm going to play around with kind of the attentiveness of and that's in fact the next slide, right? I'm going to play around with the attentiveness of the private sector, right? So one thing we wanted to do was to say, you know, these models suffer from the forward guidance puzzle, you know, especially from a policy, you know, a policy institutional perspective, right? These models are kind of problematic to think about optimal policy because often the policy paths that come out of these kind of exercises just look crazy, right? Because forward guidance is too powerful. So what we want to do is we want to introduce a way in which we mitigate the forward guidance puzzle, but we want to do it in a way that we don't affect the underlying structure of the model. So what we're going to play with is how the private sector forecasts anticipated policy shocks, right? So then you know, imagine you're in a central bank, you have your institutional model, which you've spent, you know, 10 years building. You don't then have to rebuild the micro foundations to deal with the forward guidance puzzle. So, you know, within a model where you have this sequence of anticipated shocks, right, there's basically going to be, you know, a process, right, this state variable M, which is going to keep track of promises in the future until they track forward to today when the policy shock actually hits, right? So what we're going to do is we're going to play with private sector forecasts, and they're going to forecast this M. And so what we're going to add is this kind of loading matrix, or what we call a mitigation matrix. It's going to be a matrix of elements between 0 and 1, right? And by, you know, altering, you know, what this Z matrix looks like, we can kind of capture several of the different ways that the literature has tried to kind of microfound resolutions to the forward guidance puzzle. Okay, and so this is kind of a pictorial way of thinking about that. So you know, the Z matrix flexibly kind of captures, you know, 4 different types of mitigation. One that we call kind of inattention, parameterized by a single parameter alpha. Credibility, again, single parameter. Finite planning horizon. So you know, inattention, you can kind of think of this as the Gabay, you know, kind of world that we're trying to capture. Credibility, there's this work by Richard Harrison at the Bank of England that this is trying to capture. Finite planning horizon, so this is kind of the work of Woodford. And then learning, which requires 2 parameters, but this is kind of capturing the Honka-Polya-Evans type of world. But what you can see is that, you know, fairly flexibly, this mitigation matrix can produce these different kind of ways in which expectations about the future are dampened. So the one I'm going to focus on in the next few minutes is just the inattention one, right? So here, the way to think about it is that if you're an agent in period 0, right, and there's a shock today, right, I'm fully attentive to it, right? So the color is 1. But any announcements the policymaker is going to make today about stuff they're going to do 15 periods in the future, the agent is going to be less attentive to, right? So you can see that this color turns green. Obviously, as time rolls forward in the projection, right, you kind of move horizontally down, and by the time the agent gets to period 15, they're fully attentive to the fact that this shock is about to arrive, right? So this turns yellow, you know. And so just to, you know, compare it to kind of the finite planning horizon here, you know, this is kind of the Woodford story, is that the agent, you know, pays attention to anything that the central bank announces about the year ahead and ignores everything past that, right? And as time rolls forward, of course, then they incorporate 1 more quarter of announcements by the central bank. And so, you know, what that does, right, is it's going to alter the shape of the impulse response functions, right? And so, you know, these are the same impulse response functions as before, but what you'll see is that essentially they dampen kind of the near-term effect of any of these policy announcements. So all these lines here are close to 0, and all these lines here are close to 0 at the point where the policymaker makes this announcement. So the policymaker says, well, in period 10, we're going to ease policy, right? This would be the darkest line, right? When agents are inattentive, it's going to have less of an effect today on the output gap and on inflation, right? And so then we're going to, you know, this is essentially just going to dampen the forward guidance puzzle. And again, I think this comes
just aim at kind of wrapping up, and we can continue discussing afterwards as much as we want.
Perfect. So I will then, I'm going to then skip what I wanted to show you on the zero lower bound. I'm going to show you this this slide, and then I'm going to stop there, and then I'm very happy. So that's fine from my perspective. So this comes back to Francesco's question about, well, how to what extent is the divine coincidence predicated on agents having full rational expectation. So here we can play around with this, right? So we have this idea of inattention. We have a single parameter which parameterizes this mitigation matrix Z. And so in the full attentive world, alpha will be equal to 1, and we'll be back at the full commitment case, right? This is the blue line. If agents are inattentive, right, fully inattentive, so alpha is equal to 0, right? We're kind of in the world where you might expect or it kind of conforms more to our intuition, right? What does the policymaker need to do? When the policymaker doesn't have any power to kind of manipulate expectations in the future, right? It has to very aggressively, the optimal policymaker has to very aggressively loosen policy today. So you can see, I haven't adjusted the scales. You can see how much the policymaker, this is the red line, has to ease policy, right? And then the policymaker is constrained that not only does this mitigation dampen the power that the policymaker has, but also alters kind of the relative trade-off effect of inflation in the output gap, right? And so what you can see here is that, well, the policymaker is able to dampen the effects of inflation by easing policy aggressively, but as a consequence of a widening output gap, right? So the output gap widens, and this creates inflation pressures. And the policymaker doesn't want to ease policy any further, because then the trade-off between inflation and output becomes undesirable, right? And so then you can see, as you then ramp back up the attentiveness of agents, you can see how we get from this position, the red line, where in order to raise inflation, the policymaker has to be very aggressive, to as agents are more attentive and the policymaker is able to kind of exploit expectations and exploit the power of forward guidance. This is the green line. When we raise alpha up to 0.8, we can see we kind of get back closer towards the full information case, right? Where policy, in fact, doesn't, or the policy path doesn't appear in nominal terms to ease as much as the baseline. And inflation is able to close more, but there's still this trade-off. So the divine coincidence, you can think about the divine coincidence then as being kind of this knife edge case when alpha is exactly equal to 1, and when alpha is even marginally below 1, there's always going to be a small inflation output gap trade-off, because this trade-off changes once agents aren't fully forward-looking. So let me I've taken up my time, so let me finish there, and I will ask you to go and have a look at the paper. We've got some I think some very interesting stuff in there about the zero lower bound, and especially about kind of the mix between interest rate forward guidance and QE, and especially in relation to one thing that I think is prominent in the literature at the moment is we obviously see that balance sheets of the central banks, the Bank of England, the ECB, the Fed, has been persistently large, right? So it's not like they did QE in 2009 and then they rapidly kind of shrunk their balance sheet. So one question is, well, why have these balance sheets remained persistently large? We offer one, I think, very nice kind of explanation of this, which is related to the power of forward guidance and discretion. But I will leave that as a teaser, and you can look at the paper yourself. So thank you very much, and I will stop there, Victor.
All right, lovely. Thank you, Oliver. Well, we still have a lot of time during the break, so is there any questions? Anybody wants to discuss anything more? We can stick around. I mean, Oliver, I feel like you definitely did achieve what you wanted, and that's to trigger our interest. And there's definitely a lot to dig in and understand. I was curious on the forward learning or incomplete information scenarios. Could you go back, please?
Yeah, of course.
Yeah, just here. So your method essentially tells us, look, suppose we don't have the commitment device or the optimal policy, or for some reason we can't implement. Well, the question is, can we implement it with simpler methods? And that is with the sequence of anticipated shocks. And is the takeaway from this heat map that depending on the information and expectations framework that you use just different types of shocks? In the sense, is there anything more we learn using your framework when we have these informational settings compared to an optimal policy? Or is it again replicating it with a dampening of the power of forward guidance?
So there's two things, right? So one, if you think about you want to dampen the, so if you go back to, like the original work on kind of mitigating the forward guidance puzzle, right? So this is McKay and co-authors, right? Where they essentially say, well, we take an incomplete markets model, right? And a good kind of, first order approximation of that in a representative agent model is to basically introduce this discounting in the Euler equation, right? And so, fine. The problem with that is that what you're not able to disentangle is where, to what extent the changes that you see, right, that you're mitigating the forward guidance puzzle is to do with how agents think about policy and how they forecast anything else in the model, right? So, one way to think about this is by using this impulse response function approach, we're really able to very cleanly separate this out, right? So here we're introducing essentially, the same as what, Gabay or, McKay do, which is like, I'm going to throw in a new parameter into our model, right? And this is going to solve the problem. I'm doing the same here, right? So maybe you don't like that because it's kind of ad hoc, but I'm going to throw in a parameter. The difference is I'm going to throw it in a place where it doesn't change the structural behavior of the model. It's only going to affect the way that agents the way that agents forecast monetary policy announcements, right? And so it cleanly kind of separates out that channel, which I think is really nice. And then you can.
So does it mean that they're fully rational when it comes to output gap and inflation? Exactly,
right. So so one way you might think about, so one which I don't personally like very much, but you can think about, the private sector agents, right, know how the economy works, right, and so we can kind of make this assumption of full rational expectations, right? But when the central bank suddenly, shows up and says, we're going to do forward guidance, right? And we're going to, then agents go, I don't know what this means, right? Or, so it's, one way you can kind of rationalize this is say, all this kind of, unconventional policy, right, is kind of new to agents. And so it's fair to kind of, separate them out and say, agents understand the economy. They don't understand this newfangled language of the central bank.
But then what agents actually do and what will happen depends on how large your forward guidance shocks are. And this also depends on the policy rule that you initially assumed in the model, I guess. So like you took some ad hoc rule and then you calculate deviations from that. But if you would take a different ad hoc rule, there would be different deviations and they would only be not reacting to that. So it seems that then the result might not be robust to the ad hoc rule that you choose there, or do I see that wrongly?
Yeah, so that you make two good points. So one, in the full rational expectations world, this ad hoc policy rule that we use to generate the impulse response functions don't matter. So they kind of drop out the solution, right? So I can pick a different rule, I'll still generate the same path. Now that's not completely true when you then do kind of exactly you know, you introduce this kind of these mitigation devices, right? You know, so we've kind of played around with this qualitatively. You know, it depends. You know, you can probably come up with some crazy rules, which then results look different within a class of kind of reasonable rules. The outcomes, again, I think look reasonable, but you make a good point, and maybe we should be, kind of more careful on that. In terms of, your second point, which is, and this is why I came to this slide, in terms of how the policymaker reacts to the fact that agents are inattentive, I think this is one thing that is in the paper, which I think is a really interesting result. And so if I may, I'll just explain this very quickly. So this is the zero lower bound scenario. And the question is, there's a trade-off between, the power of forward guidance and how much the policymaker wants to exploit it. And what you can see here is that under optimal commitment, we kind of get this non-monotonicity result, right? So we start off the blue line, which is kind of full rational expectations. If you lower this alpha, agents become less attentive, right? Forward guidance becomes less powerful. What the policymaker, the optimal policymaker wants to do is it really wants to make more use of forward guidance, right? It wants to stay at the zero lower bound for longer. And so you see this blue line, right? And the policymaker actually wants to stay at the zero lower bound until quarter 15. Whilst as this alpha drops further, agents become even less attentive, right? The trade-off changes. So, forward guidance isn't very powerful. So the policymaker isn't going to exploit it. And you can see that, the zero lower bound kind of shrinks back again. So you get this kind of hump-shaped trade-off. Where the result is very different under optimal discretion. So under optimal discretion, you get this kind of monotonicity result that as alpha falls, as agents become more inattentive, the policymaker always wants to promise more and more. It wants to push on that margin, right? So I think that's a cool result in the paper. But
yeah, definitely. That seems not, obvious to me at all. I definitely need to think about why that happens with. Is it fair to say that the way that you do the inattentiveness, and by the way, I mean the whole non-full information rational expectations, in your framework versus an optimal commitment solution, is that when you have optimal commitment and the bank is solving an optimal problem and giving you some optimal policy, that requires, like you said, that the agents have non-rational expectations throughout the whole model, while you could just put them in when it comes to the messages. So the bank could try to mimic the optimal path with rational agents instead of being them completely in the other extreme. Is that fair, or am I missing something?
I think this is the way to think about it, right? The problem of the central bank is it knows its impulse response functions, right? It knows how the economy reacts to policy, right? And this is the constraint that's placed on it, right? So at this point, everything it knows about the economy is embedded within these impulse response functions. And at that point, then it's going to solve an optimal policy problem, right? So it's going to solve optimal policy on the commitment, for example. Right. So all we're doing with these mitigation devices, this Z matrix, right, is we're just going to change the shape of these impulse response functions, right? So if you think, so coming back to this earlier point that I made about, you could do this optimal commitment exercise by first extracting impulse response functions from a VAR, right? So if you think that, your three equation New Keynesian model is rubbish because it suffers from the forward guidance puzzle, right? Essentially what you're saying is you don't believe the impulse response functions that the New Keynesian model delivers, right? And so maybe these impulse response functions, which embed within them this inattentiveness, right, is a better reflection of empirically what impulse response functions look like, right? So that's what we're doing. We're changing the set of constraints, but then we're solving optimal policy in the same way. The setup is the same. The only thing we're changing is, the shape of these functions.
and how that be different from having, let's say, the Woodford model. You just take a New Keynesian model with the end horizon thinking, and you solve that optimally. Would you get the same results, or is your methodology giving us something different?
The only difference is that that end horizon then impacts on the way that agents forecast inflation, the output gap, right? Here, it just impacts, the N is, I'm fully rational, apart from when I listen to the central bank, and anything that the central bank tells me about 2023, I'm just going to ignore and just think it's bullshit, right? That's essentially the way to think about it. But, I still, in terms of constructing my inflation expectations, I'm a fully rational agent.
Yeah, that sounds quite interesting, because you can, essentially the bank can now do optimal viable forward guidance, and viable in the sense that it will be believed or understood by the agents.
Yeah, I think that's a nice way of thinking about it, or selling the story. Yeah.
Yeah. Is there any other question?
Well, perfect. Thanks, guys. Appreciate it very much.
Yeah, thank you, Oliver. I was just wondering if you have another minute or so to, because the elephant in the room in this workshop is QE. We don't talk about that at all. And you mentioned that you have something on that, and I was wondering, is there anything related to forward guidance and interaction with QE that you want to share?
Well, of course, I'd love to share it. So let me do it. Why not? So what we do here is, we now need a model which has got, QE in it, right? So what we take kind of off the shelf is the Sims and Wu model that was published in the JME in 2020. This has Gertler-Crotty type financial frictions in it. And so now we have a model with two instruments, short-term interest rate and QE. We have to specify a loss function. In the paper, we actually try and do a much more kind of quantitative exercise where we think quite hard about, what this loss function looks like. What I'm going to present here is a much more stylized kind of scenario. But what we introduce, which is kind of consistent with a lot of the rest of the literature, is, that there is some cost to having a large balance sheet, right? The central bank doesn't like having a large balance sheet. And these parameterization, we're going to just penalize a large balance sheet. We're not actually going to penalize kind of the flow or the pace of asset purchases. But if you kind of think about this in the context of the ECB, it's the flow constraint that's actually, probably the bigger concern for them, right? Is not wanting to, expand the balance sheet too quickly. So there are institutional constraints. But anyway, so first of all, we construct a non-optimal path, baseline path, which is, has a very similar flavor to what you saw in the 3-equation model, right? So natural rate shock takes you to the zero lower bound, inflation output below target, and the baseline, you don't use QE. The blue line shows you, well, when you have both policy instruments, sorry, so let me start. The red line shows you, well, what does optimal policy look like again when you only have forward guidance, you only have the interest rate, and again, you get the typical result, which is that the policymaker wants to stay lower for longer. What happens under commitment, where you have access to both these policy instruments? Of course, the policymaker can do better by exploiting QE, right? So you can see the bottom right hand panel is an expansion of the bank's balance sheet, right? And that the policymaker doesn't have to, make as much use of forward guidance, right? So the first, I think what I like, the result that I like the most, right, is that, what's the difference between commitment and discretion? And the difference here is that under discretion, the balance sheet stays larger for longer, right? So you can see that you return to zero later. And the reason is that under discretion, the policymaker is not able to commit to hold interest rates low to offset the contractionary effect of shrinking its balance sheet. So as you shrink the balance sheet, that's like a contractionary monetary policy action, right? And so the trade-off that the policymaker cares about is, as at the zero lower bound, I want to expand the balance sheet because this allows me more monetary firepower. At the point where I have control back of my short rate, I want to shrink the balance sheet, but as I shrink the balance sheet, I want to keep conditions eased, right? I can't promise that in time zero under discretion. And so you can see that the balance sheet remains larger for longer. And this is the final point, and this becomes even more stark in the world in which agents are inattentive. So here we have this inattention parameter alpha equal to 0.7, right? So not only is it that under discretion, the policymaker can't commit to hold interest rates lower for longer to cushion the effect
Oliver,
of.
It was a great paper, but I'll be leaving now.
Okay, thanks. Nice
Yes.
to meet you. So, so the only difference here is that. Sorry, I lost my thought. Is that the policymaker not only can't commit to hold interest rates low under discretion, but also there's very little power of forward guidance to holding interest rates low in the future is actually going to have any impact today. And so then you can see there's much starker difference between the two, where under commitment, as soon as you exit the zero lower bound, you want to get rid of your asset purchases. Under discretion, you're going to unwind it much slower, right? And because of the lack of forward guidance, and the argument then is that this green line looks maybe much more like how we see central banks have been behaving over the last decade. That's it, Victor.
That's fantastic, actually. I think, at least for me, that's really like a highlight of the paper, because if I understand correctly, what it's saying is, so let me take a step back. We know from a lot of different literature, once you have some sort of non-rationality, the forward guidance puzzle really diminishes. Like you said, people started just with a discounting, and then once you put learning, once you put inattention and all these kind of things, the forward guidance puzzle just dampens, because the self-referential nature of the system becomes weaker. So that's fine, and that was kind of what you presented before. But now there's like a little twist in saying, because in the previous slide I was thinking, well, but the power of QE is so small. If you look at the output gap, the blue and the red in the previous slide, and inflation, yeah, they were really close. Yes, QE helps, but not a big deal. But now once you have this inattention,
no, so sorry, the QE does help. Well, okay, yeah, fine. Sorry, carry on.
No, it does help, definitely does help. The thing is that the more inattentiveness you have, the more QE helps. Is that fair?
Exactly, right. So yeah, and this is kind of what we know, right? Is that this is the point that Ghali makes, right? Is that maybe the zero lower bound isn't that much of a constraint, right? If you have commitment, the forward guidance is powerful. You can kind of unwind a lot of the effect of the constraint by exploiting expectations. And this is saying, well, once you lose the power of forward guidance, QE becomes much more important. Yeah, absolutely.
Yeah, I'm really thrilled. I actually haven't seen that before. Maybe it's me not reading enough, but maybe it's you making a very nice point.
Yeah, so sorry, this is actually more the central point of the actual paper that exists out there on the internet. But
yeah, I thought it was great. Fantastic. I definitely have to take a look. Are you aware of any other literature or papers which have this interaction of QE and forward guidance?
No, I don't actually. So this is like one paper recently came out in the JME is another Peter Crowley paper. I forget the co-author, but where they try and also kind of explain the persistence of the balance sheet, right? And so there they kind of give an argument which is about as soon as when you use QE, what you're doing is you're flattening the yield curve, and then the way that banks build profitability and build back their balance sheet is that you need a spread, right? And so the fact that you're using QE means that banks recover much more slowly, and so then you're kind of stuck in this tricky situation where now you have a large balance sheet, you kind of got to keep it large because banks don't recover as quickly. So that's kind of their explanation for this large balance sheet. But then they don't really do this comparison of commitment versus discretion. So Richard Harrison at the Bank of England has this paper on discretion, but again, doesn't really really think about the effect of forward guidance. So I think this is a new result to the literature, but obviously always happy to hear what other papers are out there that maybe I've missed.
Yeah, definitely. I think that's very interesting. Thanks. All right, I think that was fantastic.